6.5 is on proportion in triangles. There are 1, 2, 3 theorems. 3 theorems that we are going to write down, and please include the pictures. And then there are 3 examples. So that's what you're going to be writing down. So just so you have an idea. We'll do one of these at a time, and I'll come back and explain one at a time as we go. If you need to pause while they write this down, now is a good time to press the Enter button. Now that you're coming back, this one is a crack up. I had to write that. I really did. Why? Because it's called the side splitter theorem. It's the side splitter theorem. Okay, I went a little far. I guarantee you you guys are probably like thinking Mr. Prom was crazy. Maybe I am. Side splitter theorem. If a secant line is parallel to a side of a triangle, then it divides those sides proportionally. If we have something that splits the side of a triangle and it's parallel, it has to be parallel for this to work, then this little piece here will be proportional to that little piece there with the left side and the left side. Think of it as the left side of the triangle and the right side of the triangle. The little piece will be in proportion to that. Like, it's kind of neat. These ratios will be the same. That is called the side splitter theorem. The next one, theorem number 2 that they're going to need to write down, is called the corollary to the side splitter theorem. Now is a good time to press pause while students write down the theorem. And don't forget to draw the picture. Go ahead and press Enter now. Assuming you've all written this down, corollary to the side splitter theorem says it doesn't have to just be a triangle. The side splitter theorem is for a triangle. The corollary to the side splitter is that what happens if it's not a triangle? What happens if it's just 3 parallel lines? Well, guess what? If 3 parallel lines intersect 2 transversals, then the segments intercepted are proportional. This piece over this piece equals this piece over that piece. Or this piece over that piece equals this piece over that piece. The way proportions work, this piece over that piece equals this piece over that piece. They all make sense. Remember how we can do reciprocals. And we can do this side over that side equals this side over that. They'll be the same. The product of the means will always be equal to the product of the extremes. First theorem, side splitter theorem. It's for triangles, but it has to be parallel. Corollary to the side splitter theorem has parallel lines, not a triangle, but we still have parallel lines to be proportional. Last one is called the triangle angle bisector theorem. Go ahead and give students a chance to write this down and draw the picture. You can press pause or the Enter button now. Coming back to you. The triangle angle bisector theorem says if you have an angle bisector, this AD cuts that angle into 2 equal pieces. How do you know it's 2 congruent pieces? Because there's a red arc and another red arc that lets you know these 2 are the same. If this is the same as that, then this is a bisector. It cuts it directly in half into 2 equal pieces. Well, what does this theorem say? It says that if you have an angle bisector of a triangle, it divides the triangle into 2 proportional pieces. The way I remember it is the bottom right and the bottom left are going to be similar to each other. And the right side and the left side are going to be similar to each other. Meaning, this one has bottom over bottom equal left bottom over right bottom equals left side over right side. I usually do something like this over that is going to be proportional to this over that. As long as you're going the same direction, that is fine. That's what the angle bisector theorem says. Okie dokie. Okay, so 3 different ways. Proportionality is what our main idea is in this section. So when we go into these 3 examples, you can do them in your textbook if you would like. Or if you want to just write them down in your notes, you can do that as well. The one note that I little have next to number 10, number 10 is the example we're going to do together. It says, make sure your proportions match. This example is designed to trick those of you who do not pay attention. This, number 10, is something we're going to use. That's a crack up. Man, I need a vacation. That's what I do. I see this is what happens when you don't have a Thanksgiving break. I literally did not have one. So let's set it. Let's go this side, x over 10. X over 10. And what needs to be proportional to that? It's something over 30, but it's not 45. They put the 45 there to trick some of you. You're not going to put the 45 in your proportion. You're going to use the 45 to figure out that it needs to be 15. This is 15. That's 30. That adds up to 45. Then you can go little triangle over the proportion side and the little triangle bottom over the bottom of the other one, and that's going to make sense. Cross multiply. Divide. Value of x. There's our value of x. Next example. 24. In 10, I'm using the side splitter theorem. 24 is not the side splitter theorem. It is the triangle angle bisector theorem. What does it say? It says if there's an angle bisector that these sides are proportional. I'm just going to do it like this. 6x over 10x minus 4 is going to equal 5x over 7x. Cross multiply. 6 times 7 is 42. X times x is x squared. Don't forget to distribute the 5x to the 10x and the minus 4. Otherwise, you'll make that most common mistake. We don't want to do that. I'm going to subtract 42x squared. Because 42x squared minus 42x squared is 0 equals 8x squared minus 20x. Now some of you might get to this point and go, well, what do I do here? Don't invent your own mathematics. Instead, we have to use what we learned back in I can't remember, Unit 1, where we factored out a GCF and we used something called the zero product property, which is where something times something equals 0. The only way that you can get that is if you factor this out. Let's factor out a GCF. How about a 4x? And you get 2x minus 5 equals 0. And so since this times this equals 0, either the 4x has to equal 0 or the 2x minus 5 has to equal 0 because of the zero product property, right? So let's figure this out. X is either equal to 0, in this one we divide by 4. Ooh, I'm running out of room. Let me go over here. 4x equals 0. So x has to either equal 0 or 2x minus 5 equals 0. Add 5. 2x equals 5. Divide by 2. X is equal to 2.5 or 5 over 2. Same thing. Does it make sense to have x equals 0 as an answer if this side was 0 and that side was 0? Make sure you check your results and see if that makes a possible answer. Because if it doesn't, you need to eliminate it. You're honor students. So sometimes you get solutions that we call extraneous, which just means it's an extra solution that doesn't provide us any real results. We don't really need that one. This is our only real solution of the 2.5. And that one would make sense if I plugged it in, then it would be proportional. Going to our last example. As complicated as it gets. It's 35. In 35, this problem combines the side splitter and the triangle angle bisector theorem. We have an x, and I have a parallel line and another parallel line. And so I know that this is in proportion. This is a transversal, and I have another transversal. Let me highlight it. Let me pull out my highlighting pen. I'm going to do yellow. This one and this one are the only transversals. So if I want to use the side splitter or the corollary to the side splitter theorem, I can only use transversals. The 6 and the 9 are not transversals because they're not a continuous line that go through the parallel lines. So if I'm doing this, I can't figure out what x is unless I know what FC is. I got to figure out what this is first so that I can then figure that out. Does that make sense? And so then what I have to do is I got to look at this triangle and use the triangle angle bisector theorem. Because that's the triangle. I can't make a triangle out of this stuff. So I got to use the green part to find the yellow part to find the x. So we're going to do a multi-step problem here. I'm just going to do the green part first, okay? How about 6 over y is equal to 9 over 7.2. Cross multiply. Divide. And y is equal to, I've got to pull my calculator out here. 6 times 7.2 divided by 9. 4.8. Is that what I'm looking for? No. But can I use that to figure out what x is? Now that we know what this piece is, now I can go back to that other proportion. X over 7.8. Let's go this over that. I probably should switch colors now to blue. This over that is equal to, this over that is equal to this value over the 7.2. 4.8 over 7.2. There you go. Now I'm not going to do this on without a calculator. That's just ridiculous. I wouldn't expect you to as well. So 37.4 divided by 7.2. but I'm hoping you see how we're doing it. That brings us to the end of the notes. You will have the rest of the period to work on your homework in class. Be on your best behavior. Bye-bye.